So this is a very important concept, so I wanted to give this summary of the L values, the orbitals, what the orbitals are called, what shape they are, and how many orientations for each type of orbital. So the first column, the name. When L is 0, we call that an s orbital. If L is 1, that's p orbital. L is 2 is a d orbital, and L is 3 would be an f orbital. The shape, s orbitals are spherical, and p orbitals are dumbbell shaped. D orbitals and f orbitals, you don't have to worry about the shape. The number of orientations is, remember, equal to the number of m sub L possibilities. So when we're talking about s orbitals, we had 1 orientation. P's, we had 3. D's, we had 5. And F's, we had 7. So 1, 3, 5, 7, obviously that's just the odd number. So you don't have to go through and count all the m sub L possibilities. Now you see where those numbers come from. So what I want you to remember is everything on this table. L is 0, would be an s orbital, and there's only going to be 1 orientation, and so on. So this is going to be very important, and we're going to come back to this quite a bit as we use the quantum numbers. The way we use the quantum numbers is by assigning each electron into an atom into a set of 4 quantum numbers. And the key is electrons prefer to be in the lowest possible energy orbitals. So they want the lowest energy. We have to fill those first. So we're going to start with the very lowest levels, and each level will be filled before we jump up to a higher level. And another vital thing to keep in mind is there's a maximum of 2 electrons in any orbital. So if we have an orbital where we're putting electrons into it, the first electron that goes in is assigned a spin value of positive 1/2. And this is convention, just something you have to remember. That means that the second and final electron in that same orbital has to be given the spin of negative 1/2. Also, it may not always be possible, but if it is, electrons would rather be in separate orbitals. They don't want to have to share an orbital unless there's no other choice, and this is called Hunds Rule. So it seems quite complicated, but the nice thing is all the information that you need is found directly on the periodic table. All of the rules for quantum numbers are hidden inside the shape of the periodic table. The general shape is basically columns, rectangles, four basic rectangles like this. And if you count the number of columns within each rectangle, on the left side you'll find 2 columns. On the far right side there are 6 columns. In the middle, the transition metals, there are 10 columns. And the rectangle that's below the transition metals has 14 columns. So those numbers don't look like anything that we've seen before. However, they're directly related to what we've already been doing. If we take the number of columns and divide each of those by 2, we take 2 divided by 2, we get 1. 6 divided by 2 gives us 3. 10 columns divided by 2 is 5, and 14 columns divided by 2 is 7. So we have 1, 3, 5, 7. That's the number of allowed orientations. The rows are horizontal on the periodic table, and those rows represent different values of the first quantum number, n. Now, the key thing to remember when you look at the periodic table is the smallest value of n that's going to work with the rules of all 4 quantum numbers. In other words, if we're talking about the quantum number L equal to 0, that's an s orbital, the smallest value of n that will allow L to be 0 is n is equal to 1. If L is equal to 1, we're talking about p orbitals, and the quantum number n has to be at least 2 for that to work, because L starts at 0 and it goes up to 1 less than n. So if n is 1, L can only be 0. If n is 2, L could either be 0 or it could be a 1. If L is 2, we're talking about a d orbital, and the smallest value of n that works is 3. And if we talk about L is 3, that's an f orbital. The smallest value of n that works is a 4. So, key thing to keep in mind, where do we start counting our n values? We start at 1 if we're talking about s orbitals. 2 is for p, 3 is for d, 4 is for f. So 1, 2, 3, 4 is something that you can easily remember if you just remember the order S, P, D, F. That's where we start. Don't confuse those with the number of allowed orientations, which is 1, 3, 5, 7. So I can add this to the very end. This is where we're going to start counting. S's, we start counting n is at 1. P's, we start at n is 2. D's, we start where n is 3. And F's, we start where n is 4.